Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7A Day 3, some more exponent rules. Excuse me. Two of them we're talking about is when we raise a power to another power, or when we have a power of a quotient. Okay? So, start with the power to a power. I like to use this as a quick little example. If I think about what does 2 squared raised to a third power mean? This is a power to a second power. Well, this is 2 squared times 2 squared times 2 squared. Okay, there's 3 of them is the idea. Well, with 2 squareds, we know those are 2 times 2, 2 times 2, and then another 2 times 2. Look at the total number of 2's I have. Okay, I have 2 to the 6th power. My shortcut is this. If I raise a power to a power, I can multiply. Okay, 2 to the 2 times 3 power is the same as 2 to the 6th power. So that's what I get here. To find the power of a power, we multiply the exponents. A lot of people will confuse this with the adding. When we multiply with the same base, we add the exponents. When we raise a power to another power, that's when we multiply. And you have to get very good with your vocab. What does it mean to have the same base, or what does it mean to have a power to a power? So that's what that looks like there. Okay, so we're going to look at these here. Now, here's the thing to remember. If I take 2x raised to the 4th power, and that's all inside, remember, this is actually still 2x, 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 and 2x. So I have 4 2's and 4 x's. So this is 2 to the 4th, x to the 4th. Okay. This one's a very common one where people make mistakes on this. So I just want to make sure it's clear that we are doing, okay, just want to make sure it's clear that we are doing everything to the 4th power inside. Okay. So we raise a power to a power, we have like to the 1st, x to the 1st, 1 times 4 and 1 times 4 again. That's how we get those. For the second one, this one's a nice fun one because we got powers to power to a power. So I like to just work them inside out. So let's focus on those first. So we got all this to the second power right here. Remember, 8's raised to the second power, so that's 8 to the second power. G to the 3 times 2 is going to be G to the 6th power. And 4 times 2 is going to be H to the 8th power. That is all still raised to the second power again. So we got 8 squared to the second power. That is going to be 8 to the 4th power. 6 times 2 is going to be G to the 12th. And then 8 times 2 is going to be H to the 16th power. And I didn't need that parentheses there anymore. All right. Express the volume of a cube with a side length 5xyz as a monomial. So volume of q is just take every side, multiply by itself 3 times. So what I'm really doing is this. The volume here is going to be 5xyz to the 3rd power. So again, everything inside gets raised to the 3rd power. So it's going to be 5 to the 3rd power, x to the 3rd, y to the 3rd, and then z to the 3rd. That's it. The last rule we're going to cover is the power of a quotient. Okay. This one, there's not much to it. To find the power of a quotient, find the power of the numerator and the power of the denominator. Kind of works the same way as with the power to a power. Everything inside the parentheses is raised to that exponent. So if I have a fraction and that's raised to the m power, that's the same as a to the m, b to the m. Okay, so that's what we're going to do here. Everything, both in the numerator and denominator, gets raised to this 3rd power right here. So my new answer here will be 4 to the 3rd. C to the 3 times 3 is 9. D to the 3 times 3 is going to be D to the 9th. Okay, and then that's all over -5 to the 3rd power. For the next one, my personal opinion is instead of taking this 2 and doing it to everything in the inside, let's see if we can simplify inside the parentheses first. For example, I have n squared in the n. We can apply the principles of one of our previous lessons. I can subtract these 2 exponents. So I could do n to the 2 minus 1. So that's -3, n to the 3rd, n to the 1st power, 4, p to the 5th power. And everything there is raised to the 2nd power still. From there, Now I can just take everything inside, raise it to that second power. So -3 gets raised to the second power. M is raised to the 6th power. N is raised to the second power. 4 raised to the second power. P to the 10th power. Here's one specialty thing. Since -3 is raised to the second power, that is a negative times a negative. That comes out as positive. So I can actually also rewrite it like this. Okay, so just know that if I have -3 inside parentheses, and I raise it to an even power, because if it's negative times negative, it's a positive. Negative times negative times negative is still a negative. Okay, if I multiply by a fourth negative, that's back to positive. So if it's an even exponent, I can just rewrite it without the negative sign. Okay, and that's it for our 2 rules today. And that's it for examples. So you can try more on your own. Power to a power, we take anything inside the parentheses for their exponents, multiply it by the outer exponent. Power of a quotient, both numerators and denominators get raised to that exponent power. Okay. The other thing that came up today, it might be helpful. So if you kind of look at some of the try nows, yeah, it happens here. Simplify inside first. Okay. Simplify the inside before you try to do that. You can also take these two and divide them, make those smaller numbers. All right. That's it for today. Take care, everybody.